Hello, my name is Anna Molosky, and today I will be going through my final course project in the Machine Learning for Product Managers course. So starting with the problem was to build an ML model to predict the electrical energy output of a combined cycle power plant. So while I did not know at the beginning of this much about the CCPP, I did know that a supervised learning ML approach, regression modeling, would be the correct path to go, given that we already had kind of historical data with our end target values, that being energy output, and we wanted to be able to predict that as opposed to classifying any outages or something. So for my output metrics, which I'll show later, I chose the root mean square error and the coefficient of determination for my output metrics. So the RMSE is a great outcome metric, given its pretty standardized way to model error in predicting quantitative data. So specifically, the RMSE is the square root of the average of the squares of the differences between your predicted and observed values. So it gives you an idea of how large the errors are between the predicted and the actual values. The smaller the RMSE, the better the model's predictions in terms of accuracy. So on by splitting rows using random selection. And again, I wanted to have some of the fixed validation set for consistency. So going back to the model, what this does is has a step, and this is totally like a drag and drop thing that you can build together. You can build using a UI. And so I chose here, this is the algorithm part, linear regression. I have a train model step, that's where it's taking the training data, a score model step, where that's where it's taking some of that data, as well as the evaluation, which is taking in the more of that validation data. So the tool, it outputs the metrics and many different kinds of values. This one seems okay, pretty good, about 93% fit, given the coefficient of determination. So let's see how that compares to our decision tree model. And again, you can see it's the same structure, just with the algorithmic term that's here differs. So we get the same kind of stats to compare. But I didn't just stop there. I am pretty proficient in Python, so and Matplotlib and Pandas and those libraries, so I want to calculate it for myself. And also, I'm very visual, so I want to visualize actually the scatter plot to see how well that data lined up along the line of equality. So if all things are held perfect, these are linear models, how things go. And as you can see, the decision tree, even visually, has a much tighter clustering. Is a tighter clustering and distribution. So we see that these are outliers in each of the runs. So that's that. But we see that overall you get a much better R squared value. So we're capturing 96% of the variability in our target variable is being explained by our model. And of course, the higher the R squared, the better. So in conclusion, that's why I chose my final model is the decision tree regression.